So we'll do a little bit of review first. So let's,
Do I have to write this down?
yeah,
Yeah.
let's do the electron configuration for a couple. Let's do hydrogen. What's the electron configuration for hydrogen? 1s1. You're a wonderful person. There we go. So that one's easy. This tells us it's one electron in the first shell in the s orbital. All right, let's do argon, which is what we had to do up to yesterday. Argon. So what am I going to write for argon? 1s2. Yep. What's the atomic number of argon? 18, right? So these numbers have to add up to 18. So we're just going to keep filling shells until we get to 18. So we got 2, 4, 10 electrons so far. What's next? 3s2. 3p6. Okay? So there it is. Now we have 18. Now we're done. All right, so that's how far we went yesterday up to here. Today, I want to talk about elements after number 20. So let's do scandium, which is number 21. Now, before I write the electron configuration, I'm going to draw the atom first. Remember, scandium's fourth row, first one in these transition metals. So when we draw scandium, we do it, well, whatever, here's good. Scandium. So we're going to have 2 electrons in the first shell, 8 in the second shell. Anybody remember how many go in the third shell? 8. Actually, it's going to be 9. And the third shell is not full yet. 9 in the third shell, and 2 in the fourth shell. Hopefully this looks a little bit familiar. We did this 2 days ago. Okay, so looking at that now, we're going to go ahead and write the electron configuration, and obviously it has to match up with this. So it's going to start with this, right? 1s2, 2s2, 2p6, 3s2, 3p6. What comes after 3p6?
3d1.
Okay, and so I'm not going to write 3D because as the order that I'm writing them in, I like to fill each orbital that I'm writing. So we know there has to be a 4s2 here, right? Because 2 electrons in the fourth shell. So I'm going to write 4s2 next, and then I'm going to put, like you said, 3d1. Now you might wonder, why does the 4s fill before the 3d, right? What if we had 3d3? Wouldn't that be correct? But the answer is that if we did that, we would have 11 electrons here and none in the fourth shell, right? That wouldn't work. So we have to have 2 electrons in the fourth shell. So the 4s does fill before the 3d. And so that's why yesterday I only went up to the first 18 elements because the first 18 fill in order. But after that they fill out of order. And so how do we know which orbitals to fill? And that's what I'm going to show you now. And this is going to be called Aufbau. And it's a German word. I think it means to build up or to construct or something. And this, and make sure you write this down. This is going to be, excuse me, what's going to show us what order the orbitals fill in. So write this exactly the way you see me write it. Do 1s, 2s, 2p, 3s, write that meter, 3s, 3p, 3d, 4s, 4p, 4d, 4f. Make sure you're writing it exactly this way. So it should make a pyramid.
Are you any velocities?
Huh?
Are you any velocities?
This is going to be to 7. So 5, 6, 7. 5f, 6s, 6p, 6d, 6f, 7s, 7p, 7d, 7f. And I put in the rest of these just so it's easy to remember, trying to be consistent. Truth is 6f, 7f will never fill. There's no atoms big enough for that. Even 6d won't fill either, right? 3d, 4d, 5d, 6d will, but 7d won't. Anyway, okay, so this is going to tell us what order these things fill in. So let's do one while we're, no, Now let's draw the arrows first, okay. So what we're going to do is we're going to put arrows through these. Now the first orbital to fill is the 1s. Make sure you draw these arrows the same way I draw them. Diagonal down to the left. So the first orbital fills up is the 1s, then the 2s. After the 2s, we fill up the 2p and then the 3s. Then the 3p, and as we just saw, the 4s comes after the 3p, right? Yep. Then the 3d, then the 4p, then the 5s. We're just going in the order of the arrows. First arrow, second arrow, third arrow, so we follow the arrow through the orbitals. Tells us the order that we fill these things up. 5s, after 5s, the 4d is going to fill, then the 5p, then the 6s. Then 4f, 5d, 6p, and then 7s, and so on. And you can finish it. I don't think, so there's not going to be a 6s. So just stop there. So you just go down. You start with the first arrow, you work your way down, and you fill them up. Let's do a big number element so we can see how this works. Let's do, I don't know, pick one. High number. Over 60. In the 80s, 70s, whatever, high number.
69.
What is that?
Yeah.
Thulium?
Yeah.
Okay. Sounds good. TM number 69. Okay, so we're going to start writing the electron configuration. How many electrons is it going to have? 69. So we're going to keep adding until all these numbers here add up to 69. So it's going to be 1s2, 2s2, 2p6, 3s2, 3p6. We know we're just repeating what we have so far, right? When we get the bigger elements. What's after 3p6? Well, after 3p, it's 4s, right? 4s2.
That would always be 4s2?
Well, if we're past calcium, this, because we always fill up the orbitals we go past and then go to the next one. So we keep filling until we get up to close to 69, and then the last one might not be full. So right now we're at 2, 4, 6, that's 10, 12, 18, 20. So we got 20 electrons so far. Got a long way to go. After 4s is 3d. So 3d, how many does this d orbital fill? 10. So 3d 10. After 3d is 4p, so 4p6. 5s2. After 5s is 4d, the next arrow. 4d10. After 4d is 5p6. We're in a space, so I'll go down here, 5p6. Okay, 5p6, 6s2. And what's after 6s? 4f. How many does the f hold? F holds 14, right? But I don't think we have enough electrons to go to 14. Let's count. 2, 4, 10, 12, 18, 20, 30, 36, 38, 48, 54, 56. We need 13 more, right? We get to 69, so it's going to be 4f13. So there we go. Let's go ahead and draw the atom for that too, so that we can see what that looks like. I'll erase the top here. Okay, so this would be, what was this called? Thulium. How many electrons in the first shell? 2. How many in the second shell? How many in the third shell? 18. How do we know it's 18? Look, here's 3s2 and 3p6. That's 8 electrons. And then over here is 3d10, so that's 18. You have to be able to do this on a quiz or test. Take all the 3s, add them up, figure out how many electrons. What about the fourth shell? So for the fourth shell, we got 4s2, 4p6, 4d10, and 4f13. So that's going to be 2, and 6 is 8, and 18, and 13, that'd be 30, 31. 31. And then the fifth shell, 5s, 5p, so that's 8. And then there's a sixth shell, which has 2 electrons in it. So there it is. Questions? Alright, so two things you gotta be able to do today. Fill the shells in order until it's full, and the last one might not be full, right? We want to fill it up till it's the atomic number. And then you should be able to draw it too. Let's do another one. Let me work over here. Actually, now I got space down here. Alright, pick another element, high number.
79.
79 is gold.
Oh,
Oh, you're good.
Gold is AU. Alright, so we need to have 79 electrons total. So now we're going to start writing. 1s2, 2s2, 2p6, 3s2, 3p6. By the way, we're writing the same stuff, right?
Yeah.
Everything up till here is going to be the same, and then it'll have 14 in that one. I'll just keep going. 4s2, where you're following here. 4s2, 3d, 10, 4p6, 5s2, 4d10, 5p6, 6s2, 4f14, right? The F's going to fill up this time. So we're trying to get to 79. So far we got 2, 4, 10, 12, 18, 20, 30, 36, 38, 48, 54, 56, 70. So we need 79, so we need 9 more. 5d9. There we go. And if we wanted to draw an atom of gold, we need 2 electrons in the first shell, 8 in the second, 18 in the third, how many in the fourth shell? So we're going to count up the 4s, right? We'll make squares around them. 4s, 4p, 4d, and 4f. What does that add up to? 2 plus 6 is 8, plus 10 is 18, plus 14, 32, which is the most you can ever see in any shell. 5s2, 5p6, and 5d9. So 2 plus 6 plus 9, what's that? 17? 17 in the fifth shell. Sixth shell is 6s. Is that it? Yeah, I think that's it. Just 2, right? There you go. And that's the drawing. Questions? How many people can use this? How many people are confused about this? Okay. Should I do one more with this?
to do one more.
All right, we won't draw it. We'll just do the electron configuration. All right, let's pick another element.
And, P2.
What is it?
P2. That means
PT? Plutonium? No, that's PU. PT is
platinum.
platinum. Platinum's your gold, right? 78? Okay. By the way, you can look at this. This is 79. Platinum's 78.
So it would be 5D8.
It's going to be 5d8, right?
Okay.
So, well, we can go through and write it anyway. I really like overkill. So, PT. So again, 1s2. We're just following this, right? And every s orbital is going to get 2. Every p orbital is going to get 6. Every d is going to get 10. Every f is going to get 14. Except for the last one when we don't have enough electrons left. So 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10. I always remember 3d10 is 30, so that's where I kind of start counting it. 4p6. That says 5s2, 4p, 5s, 4d is next, 4d10, 5p6, 5p6, 6s2, 6s, and 4f, 14. Here's another one I always remember, because 4f is at 70, so that's a nice round number. So next is 8 more, so we just fill the d up to 8, 5d8. And that's our 78 electrons. You good?
Yep.
All right. Enough excitement. There you go. You guys are going to love this little sheet.
I don't think